Students, welcome back to my channel. It's my classes. Today I am going to discuss about the location roots theorem. If I equals to AB and f is continuous on I and f of A and f of B has opposite signs, then there exists a point C such that f of C equals to 0. Now we have to prove it. Consider that f of A less than 0 less than f of B. Let us consider an interval a1 b1 and if b1 be the midpoint of a1 b1 means I1. Then we get that b1 equals to a1 plus b1 divided by 2. If f of p1 equals to 0, then we have nothing to do. If f of p1 not equals to 0, then it must be greater than 0 or it may be less than 0. If f of p1 greater than 0, we said a2 equals to a1 and b2 equals to p1 because here p1 is the upper bound and a1 is the lower bound. Now if similarly if f of p1 less than 0, then we said a2 equals to p1 and b2 equals to b1. That is, we get a new interval I2 where I2 is a subset of I1 and f of a2 less than 0 and f of b2 is greater than 0. If we continue this bisection process, then we get some intervals like I1, I2, I3 and Ik. At last, we get a decreasing nested sequence on In where f of an less than 0 and f of bn is greater than 0. Now we have to prove that there exists a point C on In. So since the interval is obtained by repeated bisection, we get an equation bn minus an equals to b minus a divided by 2 to the power n minus 1 for all n belongs to n. Now if we consider that n tends to infinity, then we get that bn minus an equals to 0. That is, there exists a point C on I. It is given that f is continuous at c. So we get limit of f of a n equals to f of c and limit of f of b n equals to f of c. When we evaluate it, we get that f of c less than equal to 0 and f of c greater than equal to 0. It is possible when f of c equals to 0, hence the result follows. Again, we are going to discuss about another theorem, Bolzano's intermediate value theorem. According to this theorem, if I be an interval and f is continuous on I, and f of a less than k less than f of b, then there exists a point c such that f of c equals to k. First of all, we consider that capital F of x is equal to small f of x minus k. It is given that f of a, small f of a is less than k. So we get capital F of a is less than 0. Similarly, it is given that f of b is greater than k, and we get capital F of b is greater than 0. From equation 3 and equation 4, we have capital F of a is less than 0, less than capital F of b. Now, by location-Ritz theorem, there exists a point C such that f of c equals to 0. When we evaluate it, we get that f of c equals to k.